11. Next class we have discussed about acid base, concept of acid base, three different concepts. Arrhenius concept of acid and base. Secondly, we have discussed about Bronsted concept of acid and base. And thirdly, we have discussed about Lewis concept. Lewis concept of acid and base. Today, you will see the next part of ionic equilibrium. Let us consider a weak acid HA, and HA dissociates in water forming H3O plus aqueous and A minus aqueous. Remember it here that A minus is the conjugate base of the acid HA, and the conjugate base dissociates in water. This is conjugate base dissociates in water to form HA plus OH minus. Now let us consider these two cases. This is acid and this is conjugate base. This is acid and this is conjugate base. Now this is a reversible process because you know that weak acids, they do not completely dissociate in aqueous medium. They dissociate very partially. Therefore, if you write down the constant, equilibrium constant of this process, after that in method of equilibrium, you will write that K equals to concentration of H3O plus multiplied by concentration of A minus by concentration of HA, concentration of HA, concentration of H2O. So see here, as we know that water is pure liquid, therefore its concentration will remain constant. Therefore this constant multiplied by this constant is denoted by Ka. Ka equals to concentration of hydronium ion into concentration of A minus by concentration of Ha. So this is known as acid dissociation constant. Ka denoted by Ka. What is Ka? Ka equals to K into concentration of water, which is constant 55.5 mole per liter. Therefore, this is known as acid dissociation constant denoted by Ka at a particular temperature. Ka equals to H3O plus concentration multiplied by A minus concentration by concentration of Ha. Similarly, if you write the base dissociation constant, this is the conjugate base dissociation constant Kb. For the second case, this is for the first case, this is for the second case, this is first, this is second. Base dissociation constant, this is base, so it is denoted by Kb. Kb equals to concentration of Ha multiplied by concentration of OH minus divided by concentration of A minus. So look at this. We are writing Ka and Kb for a conjugate acid-base pair. This is the acid dissociation constant of acid. This is the dissociation constant of base. Now, if you write Ka into Kb, you will get this into this. So let us write down H3O plus multiplied by A minus divided by Ha. This is the expression of Ka into this is the expression of Kb. Ha, concentration of Ha, concentration of OH minus by concentration of A minus. See here, A minus cancel, Ha cancel. What is left? Ka into Kb, this is equal to concentration of hydronium ion multiplied by concentration of hydroxyl ion. As you know that this is ionic product of water, concentration of hydronium ion multiplied by concentration of hydroxyl ion, this is known as ionic product of water denoted by Kw. Whose value is 10 to the power minus 14 and 25 degree centigrade temperature. Now, from this we can write that minus log Ka minus log Kb equals to minus log Kw equals to minus log 10 to the power minus 40. this term stands for pKa. pKa is equal to minus log Ka plus this term stands for pKb. So pKa plus pKb, this term stands for pKw, and this is equal to 40. Therefore, this is the relation we ultimately get for conjugate acid-base pair. pKa plus pKb, this is equal to 14. pKa plus pKb, this is equal to pKw. This relation is valid only for conjugate acid-base pair. Conjugate acid-base pair, as you see, we have taken this example, conjugate acid-base pair AJ and A minus. This is conjugate acid-base pair. For conjugate acid-base pair, pKa plus pKb, this is equal to 40. Remember. And for another example, conjugate acid-base pair NaH4 plus and NaH3. Conjugate acid-base pair. Conjugate acid, conjugate base. Conjugate acid-base pair. This is acid, this is its conjugate base. So for any conjugate acid-base pair, this relation is valid. What is the relation? pKa plus pKb, this is equal to 40. If pKa for HA is given 4, you will write the pKb of A minus is 10, because 10 plus 4 equals to 40. Now come to the second case, acid dissociation constant, and how to find pH. We are writing the Ka value, expression of Ka for this one directly. Expression of Ka for this one, this is acid, weak acid. So Ka equals to concentration of H3O plus multiplied by concentration of A minus by concentration of H. Water has been taken as constant, and so we are directly writing the expression of K. Don't write the concentration of water, because that one is constant, that one has been combined with the equilibrium constant K, and then it is written as K. Now this one is the expression. Consider that the concentration of HA equals to C mole per liter. Consider, and also consider that it is a weak acid, therefore its degree of dissociation, this is equal to alpha. You consider before going to the next expression, next relation. We are considering two things. What are the things? Concentration of HA is taken as C mole per liter, and degree of dissociation of HA has been taken as alpha. So initial concentration of HA is C, and here there is nothing. Initial concentration at equilibrium, the concentration of the acid will be C minus C alpha. Because alpha is the degree of dissociation per molarity. You have C molarity, so C into alpha, this will be dissociated till when the equilibrium is attained. It is considered that C alpha, this much will be dissociated at equilibrium. Now C minus C alpha, this will be C alpha, because if C alpha is dissociated, the concentration of hydronium ion will also be C alpha, 1-to-1 relation, and C alpha is dissociated, the concentration of A minus will also be C alpha. This will be the concentrations at equilibrium. Therefore, Ka in this expression you can put their values. Concentration of hydronium ion is C alpha, and concentration of A minus ion is also C alpha at equilibrium, C alpha, by concentration of HA at equilibrium is C minus C alpha. So this is equal to C alpha square by 1 minus alpha. So this is equal to K. C alpha square by 1 minus alpha. In case of weak acid and weak base, most of the weak acid and weak base, the alpha is very, very small in compared to 1. Alpha is very, very small compared to 1. Therefore, you can consider consider 1 minus alpha, this is equal to 1 for most of the cases. If you see that alpha value, the maximum value of alpha is 1. If you find that alpha equals to 0.003, 0.004, these can be neglected because 1 minus 0.004 is nearly 1. 1 minus 0.005 is nearly 1. But whenever you see it is 0.5 or 0.2 or 0.09, in that case 1 minus alpha cannot be taken as 1. Remember it. So most of the cases 1 minus alpha is taken as 1. Now therefore you can write that Ka equals to C alpha square. Therefore alpha equals to root under Ka by C. So this is degree of dissociation equals to square root under acid dissociation constant by concentration of the acid taken. This is alpha. Now you have to find out the pH, and pH for the weak acid, how to find out. pH, you know that pH depends upon pH equals to minus log of hydronium ion concentration. Hydronium ion concentration. This is the expression of pH. Hydronium ion concentration at equilibrium equals to C alpha. C alpha. Hydronium ion concentration at equilibrium equals to C alpha. Clear? So if C is known, alpha is known, you can directly put their values and find out the pH. So hydronium ion concentration equals to C alpha, therefore it is minus log of C alpha. Clear it? We have written the hydronium ion concentration. If C is known, alpha is known, you can directly find out pH by using this relation. pH equals to minus log of C alpha. Suppose 0.1 molarity concentration is given and alpha is given 0.002. So C alpha 0.1 into 0.002, this is equal to 2 into 10 to the power minus 4. So 2 into 10 to the power minus 4, putting here, you can find out, you can calculate the value of pH. Okay. Another way is, this can be written as minus log C into alpha. Alpha is this one. C into root under Ka by C. So this is equal to minus log root under Ka into C to the power half. Therefore, if you break it further, it will be minus half of minus log of Ka. Then you will get plus minus log C. This you will get. Half is coming here. Minus log K, log A into B equals to log A plus log B. Minus sign is there. So half minus log Ka. I have written plus here. Then again you write minus log C. So you are getting pH equals to half into this is minus log K, that is pKa, minus log K, that is pKa, and minus log C, This is the formula to find out pH when Ka is given or pKa is given. Suppose in the problem it is given this weak acid, the pKa value of the weak acid is this and its concentration is this. Then you will apply this formula to find out pH. pKa is given, C is given, apply this formula, use this formula to find the pH of the weak acid. However, if concentration is given, alpha is given, you can directly find out by using this relation minus log C alpha. So this is the expression of pH for weak acid. What is the expression? pH equals to half pKa minus log C. So we are writing that pH equals to two expressions minus log of C alpha, number 1, and number 2, pH equals to half of pKa case of weak acid, two things are necessary. Concentration of the weak acid is necessary and its degree of dissociation is necessary. Without these two things, you cannot find out the pH. Remember it. However, in case of strong acid, only concentration is necessary because alpha is known there. Strong acid, alpha is 1. Always 1. Like HCl, H2SO4, HNO3. You will take the alpha. Alpha means degree of dissociation. 100%. That means 1. Degree of dissociation, when it is 100%, the value of alpha is 1. In case of weak acids, the degree of dissociation is 1%, 0.1%, 0.2% like this, and that's why unless you know the degree of dissociation of the weak acid, you cannot find out their pH. Now, weak base, you see. Weak base, let us consider a weak base. Ammonium hydroxide, NaH4OH plus H2O, NaH4 plus OH minus. Okay, this is activated AQ. So here you can write in this way that if you write the equilibrium constant directly, equilibrium constant Kb for these cases, Kb equals to concentration of pH plus into concentration of OH minus by concentration of BOH. If you consider the concentration of BOH, initial concentration of BOH equals to C and C mole per liter, and degree of dissociation, this is equal to alpha. You consider it, then initially you have taken us C mole per liter, here it is 0 and 0, and equilibrium it is C minus C alpha, it is also C alpha, Therefore, C, the hydroxyl ion concentration is C alpha. Hydroxyl ion concentration is C alpha. So C alpha hydroxyl ion concentration. Therefore, you can find out the POH direct. POH equals to minus log of hydroxyl ion concentration. OH minus concentration. So POH equals to minus log of C alpha. This is the POH expression of POH for weak base. Again, if you see that if you put their values, Kb equals to C alpha into C alpha by C minus C alpha. This is equal to Kb equals to C alpha square. Similarly, 1 minus alpha is taken as 1. So Kb equals to C alpha square, alpha equals to Kb by C. So similar expression you will use. For weak acid, for weak base, you will get similar expression. Here if you see the process, the water is there, H2O is there. In presence of water, the dissociation takes place, BH plus OH minus. So 2OH minus because some part is coming from water. 2 you can also write 2 here. If you write 2, the expression will be different here. The expression will be different here. It will be square. So remember the water OH minus, this concentration of water from water OH minus is neglected here. So we are writing OH minus. Now this is of alpha. Now see again if you write that POH equals to minus log of C into alpha. Alpha equals to KB by C. Therefore, if you further go, so it will be minus log of C into KB to the power half. Therefore, the same expression will come. This is equal to half of PKB minus log C. So, in case of weak acid, pH equals to minus log of C alpha. In case of weak acid, pH equals to half of pKa minus log C. In case of weak base, POH equals to minus log of C alpha, or POH equals to half of pKb minus log C. So, just you see these two formulas. This is number 1, this is number 2. This is for weak acid, this is for weak base. How to find their pH? Once you get POH, you can find out pH, because you know pH plus POH equals to 40. So, if we are to find out the pH of weak base, then after finding POH, you will convert it to pH. Okay? Next class we will start with some problems related to pH of weak acid and weak base. Okay, boys?